So we're going to talk about rational functions. Here's a reminder of what we're doing, okay? Raise your hand if you remember doing something with a graph that looks like this. Okay, let's talk about what is so special about this graph, okay? You see a couple things, maybe in red, that are special, right? What are those called? Asymptotes. All right. So we have two different kinds of asymptotes, and we'll get there. But this is why rational functions are in our polynomials chapter, because we're going to think of them as a polynomial divided by a polynomial. One thing that we will need to be careful of, and this is something that you didn't really talk about in Algebra 2, but now that we're in pre-calculus, we can. It is important that our numerator and denominator don't have any common factors. So that's something that we will need to look for. If they do have common factors, we're going to have to simplify. Okay. So it'll be important to simplify our fraction before we do any graphing. Also, something that we're going to consider, because we talked a lot about it in chapter 1, is our domain, and we're going to talk about the range too. But something that we did talk about in chapter 1 is that when we have a fraction, we don't want the denominator to be 0. So no matter what happens with our simplifying, if we have a value that makes our original denominator 0, we have to exclude it from the domain. Okay? So anything that makes our denominator 0, we gotta exclude it. Okay? Yep.
We have to do that in one form.
Yep. Interval notation. You betcha. Interval notation. Always, always, always. With a smile on your face. Yep. Okay. So let's talk about our asymptote rules. Okay. First of all, our vertical asymptote. And this is something we've kind of mentioned before, but how do we identify a vertical asymptote? Where do we need to look in our equation? Do we need to look at the numerator or do we need to look at the denominator? Denominator? And what do we look at in a denominator? Are there any rules about our denominator that we need to be careful with? We can't divide by 0. So, when the denominator is 0, we have a vertical asymptote. Okay? What I have written here, a vertical asymptote is a vertical line that our graph will never cross. Okay? Our graph will approach the vertical asymptote towards infinity or negative infinity, but we will never cross it. So we have a vertical line. We're not going to cross it. Our horizontal asymptotes aren't quite as straightforward. Okay. We're actually not going to talk about all of the cases today. I'm going to save one case for tomorrow. But there are 3 different things that could happen with a potential horizontal asymptote. Okay, the first thing that we need to discuss is that a horizontal asymptote is a line where our y values will approach that as we go to infinity and negative infinity. different things can be happening in the middle of our graph, but as long as towards infinity and negative infinity, we will approach that horizontal line. Something that is uncomfortable for some of us, it is okay somewhere in the middle of our graph to cross a horizontal axis. That is allowed. Okay, and we'll see a graph like that today. So, like I said, there's 3 rules. We're going to talk about 2 of them. So, the degree of our numerator and denominator are what we are going to look at to determine where the horizontal asymptote is. So, I don't know how I did that. Our first rule, if the degree of the numerator is smaller, so the degree of the denominator is bigger, we have y equals 0. The degree of the denominator is bigger, our horizontal asymptote is y equals 0. Does anyone remember what the rule is if we have the same degree? Yeah, very good. If the degrees are the same, then y equals whatever the ratio of the leading coefficients are. And when we get to an example, I'll show you more of what that means. I believe in Algebra 2, this is something that you did, so it shouldn't be brand new news. But if you have a second degree divided by a second degree, then you're going to take the coefficients of those terms in numerator and denominator, and whatever their ratio is where we have our horizontal asymptote. Okay. So we're actually going to do 3 examples today. One very straightforward example just to get our brains warmed up and kind of on the same page. We'll do one with 2 vertical asymptotes so you can kind of see what happens there. And then we are going to do one where we have those factors canceling out. Okay? So, when we do an example, the first thing that you need to do is factor the numerator and denominator, because if you need to simplify, you better simplify. Then I would draw in your 2 asymptotes. I would draw in your 2 asymptotes. There will only be one horizontal asymptote, but we could have multiple vertical asymptotes. Okay. Then I'm going to ask you to plug x values in to find coordinates. However many sections of our graph we have, I'm going to ask that you pick at least 2 points so you can get the shape. And then you're going to need to draw a smooth curve. Just like polynomials, these are nice and smooth. There's no corners. And then using our asymptote rules, you know that we have to approach our asymptotes. Okay? And at the very end, I will ask you for domain and range, just so you're not surprised. So our first example is pretty straightforward, and I'm not going to take a lot of time to go through it because I want to make sure we have some time for discussion on the second and third example. Okay? This is more to just get our brains warmed up. So, I'll wait for you to finish writing things down. But we got to get those asymptotes drawn in first. So, drawn in first, excuse me. We'll identify those, we'll draw those in, we'll pick some points, draw our curve. Yes, you will have a graph on tomorrow's quiz. Okay. So, graph number 1. F of x equals 3 over x minus 2. Okay. Can we simplify that at all? No. All right. Good. Then all we have to worry about is identifying asymptotes. I'm going to label VA, vertical asymptote. Okay. Vertical asymptote. Okay. Braden, what makes our denominator 0?
2.
All right. So x equals 2 is our vertical asymptote. Our horizontal asymptote, the degree of the denominator, is it bigger or the same? It is bigger. So, Guy, where is our horizontal asymptote? What?
0.
Yeah. Y equals 0. Our denominator has a degree of 1. Our numerator has a degree of 0. There's not an x up there. So since the degree of the denominator is bigger, we have a horizontal asymptote at y equals 0. Okay? Ladies and gentlemen, the hard part is over. Okay? Now we're just plugging and chugging. Okay. What I mean by 2 coordinates per section, we have a vertical asymptote. Pick 2 numbers to the right and 2 numbers to the left so we can create our shape. So, our vertical asymptote is at 2. What's to the right of 2? 3. Excellent. What do we get when we plug in 3? 3 minus 2 is 1, right? We get 3. Okay. What's to the right of 3? 4. And when we plug in 4, we would get 3 halves. Okay. Now that I have 2 coordinates, we can approach our asymptotes using those rules. Okay. Now let's go to the left side. To the left of 2, we can plug in 1 and 0. When we plug in 1, we get negative 3. And when we plug in 0, we get negative 3 halves. Sometimes you'll have some symmetry. And then we know we need to approach the asymptotes. Okay, and that's all I'm asking you to do.
Yeah, I was like,
Okay. Now, real quick, our domain. What number do we need to exclude from the domain? 2. We don't have any x values there. So let me just remind you how to write our domain when we're excluding a number. And then our range. Do we have y values everywhere?
no.
No, we have y values everywhere except 0 because what's happening at 0? We have an asymptote. So our range, we have values everywhere except for where that horizontal asymptote is at 0. Okay. Now I'll be very straightforward with you. That will not be a graph that will appear on tomorrow's quiz. Okay? But now we are warmed up. Questions before we go to the hardy examples? I didn't say hard, I said hearty. Like.
Oh, that's a good twist.
It's not bad. You're right. Okay, so now this is a little different because we have a quadratic in the denominator and the numerator. Okay, my first suggestion was for you to factor if you could in case we need to simplify. That denominator, what does it factor to? X plus 1 times x minus 1. Okay, nothing cancels, so we're fine, but that is going to help us with our vertical asymptotes. Ooh, I said it plural. Okay, Max, why is it plural?
Because there's multiple ones.
Okay, there's multiple places that make our denominator 0. Monique, what are those places? So x equals 1 and x equals -1. Be sure to write them as lines. If you don't write them as a line, you will not get full credit. Okay. I am going to count by halves so that I can get my graph on here for you. So x equals 1. X equals -1. Oh, how do I keep doing that? Keeps like moving on me.
Here you go.
All right, our horizontal asymptote. Okay, answer me this. Is the degree of our numerator and denominator the same? Yes. So Addie's suggestion was to look at the ratio of the leading coefficients, right? So Austin, what is the ratio of our leading coefficients?
2/1.
2/1. So y equals 2 is our oh, you guys didn't stop me there. I put my asymptote at 1/2 instead, or -1/2 instead of 1. There we go. Don't be afraid to speak up. If you didn't see it, then don't forget. Okay. Worst of it's over. Now we just have to plug numbers in. Yeah. Okay. So help me out. Help me out. Okay. Let's go to the very right side. For our right chunk, numbers to plug in.
3.
I would pick 2 and 3. Pick integer values that are nice. Okay? So help me out. We have 2 times 2 squared over 2 squared minus 1.
8 terms. Yeah.
So 2 8/3. Okay, and then 3. We would have 2 times 3 squared divided by 3 squared minus 1. That'd be 18 over 8, okay, which is 9/4. Okay, so we at least know this chunk over here is going to look like this. All right, you have that equation written down, right? So if I go a little bit further down. All right, now I'm going to go ahead and go to the very left side because we might have some symmetry happening. So since we have an asymptote at -1, I'm going to pick -2 and -3. Okay. So now when we plug in 2 times -2 squared over -2 squared minus 1. Yep, we get the same thing. And when we plug in -3, 2 times -3 squared over -3 squared minus 1 will give us 9/4 again. Okay. Now, I've been able to do these in my head. If you need to do some scratch work over like in the margin to get these, that is fine, okay? But I do need to warn you that you're not going to have a calculator. So this is going to have to be some mental math or some scratch work math. Okay. All right, now we got to figure out what is happening in the middle. All right. Easiest thing to plug in first would be 0. What do we get when we plug in 0? 0, right? 0 over -1, which is still 0. Okay, here is the tricky part with a graph that has 2 vertical asymptotes. 2 different things could happen. All right? We could have a graph that like snakes through like this or this, kind of similar to what like a cubic function would look like, but in between asymptotes. Or it could turn around like a U. Okay? It could go through the horizontal asymptote or it could turn around like a U. Okay? So in order to figure that out, we're going to have to pick a point on either side. We're going to have to plug in both 1/2 and -1/2. Okay? So when we plug in 1/2, 2 times 1/2 squared would be 1/2 over 1/2. So let's see. 2 times 1/2 squared over 1/2 squared minus 1. This would give us 1/2 over -3/4. So we get what? So -2/3. Okay. When we plug in -1/2, we would get the same thing. So what's happening here is it's turning around like a U. Isn't that crazy? Okay. So our domain, when we talk about the domain, we would need to exclude. Our domain, do down here, we are going to need to exclude -1 and +1. So we would need to write it like that. Everything before -1, everything in between -1 and 1, and everything after +1. Is that better? Can you see that better? Okay. Also, range as simple as everything except 2. Look at your y values. Is there a gap?
Yeah.
Yeah. So where do our y values, if we work from the bottom up, where do our y values stop?
0.
It stops at 0 and there's like a gap, right? So we would describe our range as negative infinity to 0 with a bracket because we do have a value there. And then we have values again above our horizontal asymptote. So not including 2 because it doesn't cross the horizontal asymptote, but to infinity. Okay. Probably the toughest part about this problem is going to be plugging in the numbers and getting the correct y values. Okay? Which doesn't seem like that overwhelming as far as like when you think about the math of it. Okay, we've been plugging in numbers forever, right? Okay. Okay. Just remember, it is okay if you get in between those two asymptotes. It is okay if you get something that goes through the asymptote. That could happen. I just want to warn you about that. Okay. Did you ever look at a graph like this last year?
No.
Who said yes?
Maybe once.
Okay. Okay. So these are definitely ones that you're going to want to get through on the homework to make sure you get the practice. Okay? Okay. Yeah.
Is it ever gonna cross on like the right or left, or is it only in the middle?
Only in the middle.
Okay.
Like maybe not like 0, 0 middle, but somewhere
Between the two.
in between. Yes. Yes. Last example. This is probably the most important example. Most important example. Sorry, my slippers are very noisy. What's the first thing I ask you to do? Not yet. Not yet. We got to factor first. Aaliyah, what is that numerator factor to? Okay, you think about it, that's fine. Okay, we need something to multiply to -2. Do you agree?
Yeah.
Okay, and add to 1?
Yeah.
Okay, so what two numbers multiplied?
X minus 2.
So you're saying 2, for sure 2 and what? 1. Okay, if we want them to add together to be a positive number, should I make the bigger or the smaller one?
So plus 2.
Beautiful. X plus 2, x minus 1. Our denominator. Okay. Kaylin, what is our denominator factor to?
X minus 3 plus 2.
What happens? We can cancel. When we cancel, there is a hole at the x value that you just canceled. There is a hole. So what happens since we canceled, there is a hole at x equals -2. It makes our original denominator 0, so it's an undefined value. However, since we're canceling it out, there's not an asymptote there. It goes away. But we notate on our graph that there's an undefined value by a hole. Okay, so what we're working with is f of x is x minus 1 over x minus 3, but there's going to be a hole at negative 2. So let's talk about what that's going to look like. Our vertical asymptote. There's only one of them because we're looking at the simplified fraction is x equals 3. You'd be worried if I wasn't, right? This is really driving me nuts. Okay. Degrees of numerator and denominator are, okay, they're the same. So we're going to look at the coefficients to get our horizontal asymptote of y equals 1. Since we've canceled, has anything changed in our process? Nothing has changed. We identified asymptotes, same as normal. We're going to plug in values, same as normal. Which one am I going to tell you to plug into, though? The original or the simple one? The simple one. It's not going to matter. You're going to get the same numbers, but which one's going to be easier to plug into? The simplified one, okay? So we have an asymptote at x equals 3. Let's plug in 4 to this simple one. 4 minus 1 over 4 minus 3 is 3, right? Let's plug in 5. 5 minus 1 over 5 minus 3. Okay. Next, we're going to go to the left side, just like we would normally. So since our asymptote is at 3, I'm going to pick 2 and 1. 2 minus 1 over 2 minus 3. Is negative 1, isn't it? Okay. But 1 minus 1 over 1 minus 3. Okay, everything has been the same until now. We have a hole at x is negative 2. So when I plug negative 2 into our simplified function, negative 2 minus 1, negative 2 minus 3, we get 3/5. So at x is negative 2, y is 3/5, I am going to draw an open circle and use that to draw that part of the curve. There's just a hole there. It looks the exact same as x minus 1 over x minus 3, but there is a hole right there. Which one did we use to plug into? The simplified one, okay? Now real quick, when we talk about the domain, we have to exclude the hole and the asymptote. So we have to exclude negative 2 and 3. Guess what? Same thing for the range. For our range, we have to exclude the hole at 3/5, and we have to exclude our asymptote at 1. Okay? The hole and asymptote both have to be excluded from domain and range because there's not any values there. Okay? Your homework is pretty short, I believe. Take a breath. You have 4 graphs. I think 3 matching and 4 graphs. Okay? 4 graphs. You better do them or try them. 4 graphs. Hey, let me stop this recording real quick and I will show you something.